Hello and welcome. In this video, we're going to talk about the rate of change and the difference quotient. Our goal in this video is that we can find the rate of change between 2 points or on a given interval of a function, and that we can use that idea to find the difference quotient. So let's go ahead and jump right in. So the first time you really talk about rate of change or average rate of change is when you're talking about slope. And slope is just the change in y, y2 minus y1, over the change in x, x2 minus x1. And typically when we think about slope, we really relate this to the idea of lines, but a line is just something that has a constant slope. We could find y2 minus y1 over x2 minus x1 as long as we have any 2 points. We could find the average rate of change, or the AROC, of any function over a given interval. I think the best application of this is that in our car, we have a speedometer which tells us our average speed, and we can use that to determine how much gas we need, how far we need to go. I think you get the idea. So let's go ahead and look at an example. We're going to find the average rate of change of the function below on the interval 2 to 4. So what we really need to do is we need to know the 2 output values. So we need to know what f of 2 and f of 4 are. Those are like our y2 and y1 values, and we're going to divide that by 4 over 2. So if I substitute 4 into the function here, I'm going to get 16 plus 1, which is 17. If I plug 2 into the function, I'm going to get 5. 4 minus 2 is 2. So here I'm going to get that the average rate of change of this function, so of f, on the interval from 2 to 4 is going to be 12 divided by 2, or 6. So if we think about this visually, let's put the graph of x squared plus 1 up. We're not saying that the average of the function everywhere is 6, because right here it looks like there would be a slope of 0. We're saying over this little red piece from 2 to 4, if we found the slope between those 2 endpoints, that slope would be 6. Over here, that slope would be negative. Down here, it would still be negative. So that's why we have to have an indicated interval over which we're going to talk about this average rate of change. So before we move into tying this to the difference quotient, let's just look at a couple more quick examples. So I'm really going to encourage you here to pause the video and try and work through numbers 1 and 2 on your own. For both of these two problems, you're going to be using this function here defined to be x cubed plus 1. You're given your intervals, and go ahead and pause the video and work through them on your own. So here's the setup for the first one. Now we just need to evaluate those 2 points. So if I plug in -1, I'm going to get 0. If I plug in -2, I'm going to get -7 over +1. So for number 1, the average rate of change on f on the interval -2 to 1 is going to be 7. So I'm going to go ahead and clearly communicate my answer there. Similarly, for number 2, we're going to find f of 3 minus f of 2 over 3 minus 2. That's going to give me 28 minus 9 over 1, which is going to give me 19. So the average rate of change of f on the interval 2 to 3 is 19. And there we have it. Let's do one last example on average rate of change, but let's do it specifically pulling those values from the graph just to make sure we're reviewing those skills as well. Okay, so here we are given the function for f of x, but we're also given the graph. Now we can obviously plug in the points to the function in the way that we just did in the previous examples, but since we're given the coordinates, and it looks like -1 and 0, it looks like we're going to be able to use the points that are clearly indicated on the graph to help us out. Let's just make sure we're pulling those points and finding the difference quotient without actually having to evaluate the function itself in terms of plugging numbers in. So for part A, we're looking at f of 0 minus f of -1 over 0 minus -1. That's going to give us 0 minus -8 over 1, which is going to be 8. So the average rate of change is going to be 8. Go ahead and pause the video and work on B and C on your own, and then unpause the video and see how you did. So here are the solutions to each of those problems. I encourage you to pause the video, make sure you found the correct values and identified any mistakes that you made, and then we can go ahead and move on to the difference quotient. So the difference quotient is just this average rate of change over the interval having length of h. So if we're starting at x, we're going from x to x plus h. And what we're going to do, and you should have done in pre-calculus, is we're actually eventually going to look at the limit as h gets smaller and smaller and smaller. But if you're being asked to just evaluate the difference quotient, what you're going to do is you're going to substitute in x plus h into your function. So you're going to take x plus h, plug that into each of the x's in your function, subtract f of x, divide that whole thing by h, which is the length of your interval, and you're going to simplify as much as possible. So looking at this example here, the very first thing I'm going to do is I'm going to evaluate f of x plus h. So I'm going to plug x plus h in for each of my x's. And then I'm going to go ahead and subtract f of x, which is x squared plus x, and I'm going to divide that whole thing by h. So now we're going to need to use a little bit of algebra. We're going to expand here, x plus h times x plus h. We're going to distribute this negative, and then we're going to combine any like terms that we can in the numerator. So here is everything expanded, and then a bunch of things are going to add to be 0 here, and this is going to happen all the time. So x squared and negative x and positive x. So let's just rewrite what's left after we subtract those things away. And what I want you to notice is that every single term has an h, so we can divide each of these terms by h. So 2x, h divided by h is just going to be 2x, so this h can divide out because it can divide out to each piece. H squared divided by h plus h divided by h, and here is my simplified difference quotient. This is going to play a big role in our first unit when we start talking about limits and the limit definition of a derivative. So I really want to make sure we understand this. So let's just put up a few more practice problems to solidify this in. All right, I'm going to encourage you to pause the video and try and work through these 3 problems on your own. Number 6 is tricky because it's not going to seem like anything simplifies, but if you use an algebra 2 trick, something will. And then unpause the video and see how you did. Remember, you're really thinking about f of x plus h minus f of x over h. So here is the setup for each of these steps. Now I'm going to go ahead and simplify. Okay, so on number 4, everything is going to simplify away except for 3h over h, and those h's can divide out to get 3. This should make sense, because this function is a line, and the slope is always going to be 3, so the difference quotient will always be 3. For number 5, this difference quotient is going to expand that quadratic out, and we simplify everything we get here, and then we can divide each of these terms by h, which gets us here. Now, number 6 doesn't simplify as obviously using the algebra that we have before, but it can simplify if you use the conjugate. So if you multiply the numerator and the denominator, and I'm going to just write this, by x plus h minus 2 inside the square root plus the square root of x plus 2. So multiplying by the conjugate of this numerator. When we do that, we will end up with x plus h minus 2 minus x minus 2 all over h times the conjugate minus 2 plus. And why is this helpful? Well, if you distribute this negative in the numerator, then everything is going to go away except for h, and this h can divide out. So we actually can get this down to 1 over the square root of x plus h minus 2 plus the square root of x plus 2, which, when we extend this on with our calculus, is going to be a very helpful place to be. So let's recap what we have covered in this video and go ahead and wrap up. Okay, so let's recap what we were trying to do in this section. We were trying to learn or review how to find the rate of change between 2 points or on an interval, and how to extend that idea to the difference quotient. So really, this whole section was just about finding the slope. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.